Okay, so this is a telescope, obviously, and what's amazing about this is it's a handmade Japanese telescope.
Now, when you say it's handmade, what do you mean?
I mean, every single bit of this is handmade, not machine-made. So they used the Japanese people that make these telescopes. It's called a Takahashi, and they do sand casting to make all the components of the telescopes. Then Canon have designed all the lenses. It has a series of lenses inside, and every single bit of it is handmade. Even these little finder scopes are handmade. Yeah. So it has on the far side.
How does that mean that each one is very slightly different? No.
No.
Okay.
No. I mean, I suppose it's the precision with which these are made.
Amazing.
I mean, just an incredible thing.
What a gorgeous looking thing.
Yeah. So I love it as much to look at as to look through.
Yeah.
You know, even the serial number is all done according to the current emperor when it was made.
No way.
Yeah.
Oh man, that's fantastic.
Isn't it?
Yeah.
So this is a travelling telescope.
Right.
So if you take this clamp off, the telescope actually screws in half, and then you can put it in a handbag and take it anywhere in the world. I know. So I bought it as a travelling telescope when it was lockdown, because a really important thing for me was thinking that one day we were going to get out of this.
Right.
And I was going to be able to take this telescope to the places in the world. Well, the southern hemisphere is somewhere I'd love to go, because you can see completely different parts of the sky. There are two clouds, the Magellanic Clouds, and they're satellite galaxies that are colliding with our Milky Way galaxy, but you can only see them from the southern hemisphere. So to have a telescope like this to look would be amazing, right?
Yeah, absolutely.
But what I didn't expect was that in my own back garden, this little guy gives my bigger telescope a run for its money.
Really?
It's a really, really amazing thing.
So you have this out in the back garden. You obviously don't live in a city surrounded by lights, which is a huge advantage.
A huge thing, yeah. So I live in Roundwood in County Wicklow, which has pretty good dark skies. We're right up against the national park that the Sallygap is in. So to the north, we do have a bit of sky pollution from Dublin, but to the south, east and west, it's absolutely perfect. So so I have this on a computerized mount, so it just finds things and tracks things automatically. So it is pretty amazing.
But you have to know what you're looking for then.
You do. So I normally would put together a plan, depending on the time of year, of what I want to see that night. Yeah. I mean, I've been into it for a long time, but it was really during lockdown that I got big time into it. Yeah. So I'd normally make a plan of the things that I want to see in a night, and map them across the sky so that you don't start here and then go to the other end of the sky and then have to go back again.
There's quite a lot involved in it then, isn't there?
I mean, you can go out and just look at it.
I mean, that's what I do. I just go out and I look up at the sky and I just feel tiny and insignificant almost immediately.
Me too. Yeah. And sometimes I don't bother setting up a telescope. I go out and I sit on a sun chair with the binoculars, and they can be the best nights, because you just look around, you just find you find things that you weren't looking for.
And the thing that always occurs to me is some of the things I'm seeing here aren't there anymore. Absolutely. Some of the light I'm seeing here is from something that is no longer actually there. I mean, how do you wrap your head around that?
Totally, yeah. Some of the things that I'm looking at, they don't look like that now. They look like they did 20,000 years ago, for example. Yeah. And I'm looking at it, but because it takes the light that long to travel, I'm not seeing it as it is now, which is amazing. I mean, sometimes your mind can barely understand what it is you're looking at.
That would really blow my mind. Yeah.
It is amazing. Like the sun. The light from the sun takes 10 minutes to get to us. So if the sun blew up, we wouldn't know for 10 minutes. Isn't that amazing?
It's kind of bonkers. It's absolutely bonkers.
Yeah. So yes, when I was doing this, I suppose, we want to record something, don't we? So I was in a notebook recording the things I'd seen and what I'd planned, and et cetera, et cetera. But then I didn't want to start taking photographs because for me, the magic is sitting and looking at that thing in the here and now, even though you can't see light at night. So everything's black and white. It's fuzzy. You don't see the definition you would if you took a photograph. But I started drawing the things.
As you do.
Well, I don't know. So I decided to do white on black because that's what I'm seeing.
Exactly, yeah, amazing.
So he got a job, I think he was recording things for an astronomer and ended up becoming one of the most successful astronomers of his time. But he catalogued over 100 of the brightest objects in the sky. And still today we use Messier's catalogue to look at things. And there are other catalogues as well. There's the Caldwell catalogue, which Patrick Moore, a very famous astronomer, put together, and the New General catalogue. But the Messier catalogue is really popular.
So that's what you use when you planned what you want to see, and you just key that into your computer and it talks to the telescope.
That's
and
it, exactly.
Finds the things.
So you just have a remote control that controls the gears on the telescope, like the computer, I suppose. So this is the Great Globular Cluster in Hercules, which is Messier 13. Okay. So you just put M13 into the telescope and it will find it, and then it tracks it, so you don't have to keep moving the telescope.
That's amazing, but like it's not that easy to make a drawing like that,
No.
On all those little tiny dots, and each one exactly probably where you saw it, and it makes you sort of look at things in a different way when you're drawing them, doesn't it?
Definitely. I mean, it makes you pay attention to what you're seeing. Yeah. You don't just glance down the telescope and say, oh, that's very nice. You actually really look. And the more you look, the more you see.
Amazing, isn't it? Yeah. So are you an astronomer then?
No, not at all.
Not your day job.
No, I'm a vet.
You're a vet.
And a virologist, I
suppose.
Your name? Nicola Fletcher.
So what is it you actually do then for your day job?
So for my day job, I study viruses, and more particularly, I really am fascinated by viruses that transmit from animals to humans.
Zoonotic
viral diseases.
We've heard a lot about those recently, haven't we?
Absolutely. One of our favourites, or not so favourites, SARS-CoV-2, which causes COVID-19. So I mean, the current thinking is that must have come from a bat. And whether it went through another animal before it first infected humans, we don't know. Maybe not. But certainly it's an example of a zoonotic viral disease. Yeah.
And this is so this must be, I can't see anything else that on the table here.
No, this is my only tiny little tube. So when the COVID pandemic broke out, I was working with high containment viruses before. I've worked with them in other jobs, and I sort of felt that I needed to do something, So I did a few bits and pieces. First did contact tracing and some other things, but then because we had the high containment lab, I decided to start working on SARS-CoV-2. So imported a virus for research from Italy.
No, you make that sound very easy. I imported the virus.
I know. So went through great hoops and lots of paperwork and permissions, etc., etc. You have to have permission to bring it into the lab, permission for the import, permission to get it from the person from whom the virus was originally taken. Yeah, and this is the vial that the very first virus for research came to Ireland in.
The very first sample of SARS-CoV-2.
Very first sample of SARS-CoV-2. And this came from an Italian patient, and it came at the time when, we were seeing on the television all these people so sick with COVID in Italy. And so this, I don't even think it was called SARS-CoV-2 when it came, because the tube says NCOV, which means new coronavirus.
Wow.
Yeah. So this came in June 2020. So we were the first in Ireland to get the virus, the culture systems up and running here.
So that's what you were doing during the lockdown when you weren't looking at the stars at night?
Yeah, so I drove in from Wicklow every day, worked in the high containment lab with the virus.
And the place was abandoned here? There wouldn't have been anything?
This place was abandoned. It wasn't. we've been coming to UCD for years, and it's always buzzing.
A hive of activity, people, noise everywhere.
Exactly. And it was absolutely empty. There was
Overnight,
absolutely nobody around.
So it was like a sort of a ghost town.
Yeah.
Really strange.
Yeah, really strange. So I used to come in, park in the O'Reilly Hall car park, and literally walk up the ramp to the vet school and never see anybody and do my work and go home and go past all the police checkpoints, and they knew me because I saw them twice a day. So, but I started walking around the campus after a while, going out at lunchtime. None of the cafes were open, nothing like that. So you'd bring in your food with you. And but I started walking around the campus, and it was completely deserted. It was really eerie. And I remember I used to walk, there's a woodland walk around the perimeter of this campus, and I used to walk the woodland walk. And there was an office I used to walk past every day, and it was completely empty and still, like everything else, except for just one little thing. It was a little plastic flower, one of those solar powered ones, and the leaves went up and down. And it was the only moving thing, really. Obviously there was wildlife and things, but the only predictably moving thing in a building.
That you could find.
That I could find.
Absolutely weird.
And it became so eerie, I, after a while, stopped walking around the campus.
Okay.
Yeah.
So what were you actually doing in your lab with this virus?
Yeah, so we were, at the beginning, we were studying a new antiviral. So I'd been working on this antiviral with a small company who developed it in Donegal. And we'd shown that it was antiviral against lots of different viral infections. So viruses with an envelope on them. Mm-hmm. So it's basically a coating they have from the host cell. And we had looked at SARS-1, and we knew that this was antiviral against SARS-1. And I was driving home, early in the pandemic, driving home from the contact tracing centre. And the guy who owns this company rang up and he said, "We have to do something." So I was sitting in the petrol station. I said, "Yes, okay, fine, let's go for it." So we need to get the virus into the lab, and we need to get all the culture systems up and running, and then we can test the antiviral. So
that's what you were doing?
So that was the thing that really made me so quickly get the virus in and get everything up and running and start testing the antiviral. And it's completely antiviral against SARS-CoV-2. So we're developing it as something that you could use to treat the upper respiratory tract, which is where the virus replicates.
Particularly more so now that it's actually mutated further, it's sort of more...
That's true, yeah, actually, yeah. The Omicron seems to replicate better in your upper respiratory tract. And if there's more virus there, you could imagine a situation where, for example, if you cough, there's more virus coughed out and it's more likely to transmit to somebody else.
So that's amazing that all through the lockdown you were here working on this antiviral and you were seeing positive effects, and that you now might be able to actually market it or put it into production, hopefully.
Yeah, that's it.
As a very easy spray.
Exactly, it's something you could just spray when you get on an airplane, when you go to a restaurant, any place that you think you might be at higher risk. I think the other exciting thing, I suppose, is that it works against other enveloped viruses too, so common colds, flu. So it has potential, I suppose.
Yeah, going on.
Yeah, so that was one thing I forgot to actually say, was that, so this tube arrives from Italy, presumably, I don't know, was it in a box?
It was in several boxes, yeah. I mean, you put it into multiple boxes with loads of absorbent material. It was on dry ice. I mean, this enormous box arrived. And, when you open up all the different packages, and then eventually in the high containment lab, there's this tiny, tiny tube.
And what was actually in it?
A tiny bit of pink liquid in the bottom of it.
And why was it pink?
Because it's in cell culture media.
So it's growing in cells, and this is the colour,
Yeah, so that's why it's pink. But I mean, it's a tiny plastic tube with a tiny bit of pink liquid in it. Mm-hmm. And it's got in there the cause of the world's massive problem and all these deaths and sicknesses.
It's just incredibly hard to wrap your head around such a thing.
Very hard. And well, I suppose you can believe it when you take it out and you put it onto some cells and it annihilates them. And then quickly, very quickly, like overnight. And then we took some photographs on the electron microscope of the viruses within the cells.
Were you kind of like terrified?
No, I wasn't terrified. No, I mean, I'd worked with very, very dangerous pathogens before. I mean, I'd worked with animals, cattle infected with mad cow disease, animals infected with rabies, you know, so I suppose in the grand scheme of things, it wasn't scary because I've been trained to do this, but it was difficult to get your mind around it.
Well, yeah, I mean, it must have been strange that you were there in the lab holding this vial that contained this virus that had every person in the country locked up behind their front door. Weird.
Yes, you've put it exactly. That's exactly what was so weird about it. Yeah.
That's great.
That's amazing.
Not only for SARS-CoV-2.
It must be absolutely amazing to be somebody who has actually been able to do something, not like loads of other people. And really cool to be a virologist and to be able to sort of step in and actually do something useful. Thanks a million for telling us that story. It's really, really, really interesting to talk to you, Nicola. I'm Lorna Donlon. I was an artist in residence in the Conway Institute for a year from September 2020 to September 21. And that's when I started to talk to scientists and learn about these amazing stories that they have. And that's why I'm sitting here talking to them. So thanks a million.